So let's talk a little bit about loops. Loops is another data structure that we have in Python and many other programming languages, and in which we define a certain group of instructions or statements that we want to be executed if a certain condition is true or false, depending how you do your logic, right? In Python, we control our repetition structure with two of them, two structures, while or for. In other languages, they have for each, do while, and so on and so forth, but they pretty much do the same thing. They repeat something given a certain condition is set true or false, right? Verify as true or false. So first, let's take a look on while and see how it goes. For a while, we need to say while something is true. Let's run this here a couple of times. So let's start with a counter. We're going to call that counter I. And then say, hey, if I is less than 10, just print it out something. Why not print it out the value of I, right? So number is, and then we go there and print the value of I. But here we have to remember to transform this into a string because we are concatenating two strings, right? We are concatenating this and this just to make sure. We go there, and now after we do this, we have to make also sure to add 1 to our counter, because on each iteration we're gonna add 1 to this value right here of I, so we can continue and get out of this loop eventually. If you find this notation a little bit weird, this is pretty much the same as saying, hey, take the previous value of I and sum 1, and then we'll have the final result. All right, so if you go there and print it out this, it's gonna print it out the first value, which is 0, because this is true, and then what is the current value of I is actually 0. So 0, 1, 2, 3 until we reach 9. So until this condition here holds true, we're gonna repeat this over and over again. As we saw, it's not very common to use a while with a counter in Python. Why? Because different than other languages, I mean, when we repeat something, we pretty much don't care about the counter itself as long as it do it for all the elements, right? So let's take a look on for instance. If we have 4x and let's say we now have a range, which is a range of 10 again, and we say, hey, print it out the value of x. And if we do this here, we're gonna have the same result as we had it before. So we don't care about how the counter is working out. Why? Because we establish a range that goes from 0 to 9, and we say, hey, for every value that is within in this range here, I'm gonna execute this line. So if we think about it, I don't care about the counter for this. Let's leave the programming language do that for us, right? So this is pretty much different than other language, as you would have something like, hey, int I equals 0, and then you would execute this, and then as long as I is less than 10, and then I plus plus. So this construction right here, it's pretty much the standard for other programming language, but not for Python. We use, this is more close to a for each than an actual for here, right? Sometimes we want to work in a certain condition. If we find a certain value, or if we find something that we're looking for this, we want to either break our loop or continue, and because of that we have two structures that can help us. One is the break and the other one is continue, and of course they are separate structures, right? So let's say here we have the same thing that we had it before. So for x in let's say the same range, why not? And we have here the range of 10. But now I want to do something. If the value of x equals 5, I'm going to say, hey, I printed out and I know the value now, so found it. And other than that, else I'll just say, hey, just print the number, right? So if we have something like this, and by the way, after we find our number, well, first of all, let's just run this and see how it goes, so then we can continue and use here the break structure. So if we do this here, we'll say, hey, we are going from 0 to 10, 0 to 9, and then we printed out all those values, but the moment that x assumes the value of 5, I'm gonna print it out this message, right? And if that's not the case, I'll just go ahead and print it out. The thing is, let's say after I found my value, I don't want to traverse the entire range. Let's say here, this is a range of 10,000. That would be too long, right? So for that reason, we can do something as this. We can use the break structure. So the moment that we run this here and we find our number, we get out of our repetition structure. So we don't need to traverse the whole thing, which is pretty neat, right? Needless to say, I mean, the same way here right now, we're just traversing numbers and counters and I mean, and so on and so forth. Most of things that we're gonna be facing off in the future, they don't necessarily need to be composed as numbers. So we can have something like, hey, let's say here we have a banana, and then we have an orange in our list, but this is a messy list, so I also have the number 42 there for whatever reason, and then we have a condition here which is truth. So what we can do is, let's say I want to traverse all the fruits, so for each fruit in fruits I want to do the following: print it out the element. And what is the element? The element, it's being considered fruit. So as we can see here, we pretty much don't need to control if and what element inside our list is being presented. I mean, does it matter if it's fruits 0 or fruits 1 and so on and so forth? Well, not really. Why? Because with this structure right here, we guarantee that for every single element inside our object, inside our list, it's going to be presented to us. So if we run that, we'll have that the first element was a banana, and then was an orange, and then was the number 42, and then it was true, right? We can also, I mean, you can verify that every time the data type here is changing, as simple as this. So the first element is a string, the second is a string, then we had an int, and then we had a boolean, which is pretty nice. The thing is, sometimes we need to use we need to know which element, or we need to control the index in which we are traversing because we want to use it. So in order to do this, we can have the enumerate function, and that enumerate function returns two values for us. It returns the index, and then it returns the element itself. So we can say like this. Let's say we have, let's print it out in a nice way. So we have item, and then what is our item here? It's controlled by the index. Let's concatenate this with our fruit. Well, not everything here is a fruit, but I think you got the idea. So if we try to run this here, let's see what's going to happen. And of course, some data that we have here, they are not necessarily a string, so we can concatenate, right? So let's make sure we transform this here into a string. And we transform all the elements in a string just because we are concatenating a bunch of strings, right? And then if we run this again, we'll see there's a space missing here. I'm sorry. So as we can see here, for each tuple, and we're going to talk about this later on, so think as what we're doing is we're taking the list that we have, and for each object inside that list, we're returning a pair of the element inside that list and the index controlling that list. So when we retrieve that information, we're going to print it out, the index and the element with respect to that given index, right? So here we print it out that what is it, item 0 is banana, so we have here 0, 1, 2, and 3. So 1 is orange, 2 is 42, and 3 is true, right? So thank you and happy coding.